Okay, so today we're looking at 5.1. It's called Quotient of Monomials. So what is this word quotient? Divide. Okay, so one way we show division is by using a what? A fraction, right? Okay, so if you have a monomial that looks like, example number 1, 30 over 48, okay, this is like basically a pre-algebra problem, right? This is technically a monomial, and it's a quotient. You want to simplify it, right? You want to get it into its most basic form. So this one's pretty easy. You're just going to do what? By 6, okay? So you're going to take that numerator and divide by 6. You're going to take that denominator and you're going to divide by 6, and you should get 5/8. And that's showing it like on a pre-algebra level, okay? Then when you get to algebra 1, you start throwing variables in there, right? So you get a problem like 9xy to the third over 15x squared y to the second. And you need to simplify it. Okay, so a couple ways to attack it, right? I always start with the numeric part first, right? So you've got a 9 and a 15. Can you reduce that? Yes. They're both divisible by 3. So 3 goes into 9 3 times. 3 goes into 5 5 times. Then in the numerator, we have an x to the first, and in the denominator, we have an x to the second. So x to the first is like x, right? So if we simplify this to 3 times x, and in the denominator, we have 5, and then x squared is times x, one of them will cancel. So one way to do it with the exponents is to completely cancel that one, and then to take that that exponent and change it to a 1. You have to write kind of small, right? And then same thing with the y's. Y to the third is y times y times y, and y to the second is y times y. So how many of those will cancel? 2. Cancel off 2 of them. That means you should have 1 left in the numerator, and the denominator completely cancels out the y part. Okay, so you're going to write what's left. The numerator, what's left? 3y. In the denominator, what's left? 5x. Any questions on example 2? All right, example 3. So we've got 24x to the fourth, t to the third. In the denominator, we've got 32x, t to the fifth. Looks pretty similar to example number 2. All right. So we'll start with the numeric part. 24 and 32 are both divisible by 8. So 24 divided by 8 is 3. 32 divided by 8, I got 4. In the numerator, we've got x to the fourth. In the denominator, we've got x to the first. So the x to the first cancels. X to the fourth becomes x to the third. And then we've got t to the third and t to the fifth. So t to the third completely cancels. T to the fifth becomes t to the second. So for your answer, you write what's left. You've got a 3. You've got an x to the third in the numerator. In the denominator, what's left? 4. X is gone, but you've got that t to the second. All right. So let's talk about the algebraic rules. Okay. A to the m power times a to the n. You want to do what with the exponents? Add them. So you keep the same base, add the exponents. AB to the power of m. Make sure each of the parts inside the parentheses goes to that power, so you're going to have a to the m, b to the m. Even if you have a numeric part, like a coefficient or a is a number, make sure the numeric part goes to that power as well. All right? A to the m to the n. Whoops. We want to do what with the exponents? Multiply them. A to the m dot n. Okay? So these three we saw last chapter, right? So what about a to the m over a to the n? You want to subtract the exponents. So it's kind of like this first rule where you're multiplying, you add the exponents. So here you have the same base, you're dividing, so you want to subtract the exponents. And depending where the larger exponent is whether you would move it to the numerator or whether you would move it to the denominator. I'll show you what I think I have one where I show you what I'm talking about. All right, how about a over b to the power of m? With this one, you want to make sure, just like we did right here, that everything goes to that power. So the numerator goes to the power of m, the denominator goes to the power of m. Okay. And the last one is a to the negative m over b to the n. So if you end up having a negative exponent, you're going to move it to the other location. So right now, if it's in the numerator, we're going to move it to the denominator, and it's going to become positive. If it started in the denominator, you'd move it to the numerator. So in the denominator, now we'll have a to the m and b to the n. And it looks like we should have 0 in the numerator, but we need to actually write a what? 1. Okay. All right. Example number 4. Let's try t to the third over 3 to the power of 2. Now, this one's pretty easy, but the common mistake is that students will take the numerator to the power but forget to take the denominator to the power as well. So I'm just pointing it out so that you don't forget to do that. You want to take t to the third also to the second and the denominator to the second. So when you simplify it, you have t to the 6th power over 3 squared, which is 9. So t to the 6th over 9. All right, one more. Example number 5. 5x over 4y squared times 2y over x squared to the third. There we go. That's a y. That help? All right, so we want to multiply these two guys, but when you look at the first fraction, it looks pretty simplified already, right? So for now, just leave it. Let's see if we can simplify over here, okay? We've got a power of 3 on the outside. That means everything inside needs to go to that power, including the 2. So this is going to be 2 to the third power, y to the third power, and then in the denominator, we've got x to the second, but we also need to take it to the third power. Okay, so write it out like that. Then we will see if we can reduce or whatever in the next step. Okay. All right, let's simplify this 2 to the third. What's 2 to the third power? 2 times 2 times 2, which is 8. And the y to the third looks good, but how about x to the second to the third? So 2 times 3 is 6. So I'm just going to rewrite this as x to the 6th. So I'm going to simplify a little bit before I see if I can, I can cancel the 4 and the 8, right? 4 goes into 4 once, 4 goes into 8 twice. Now let's see what we've got. We've got a 5x, a a 2y to the third. In the denominator, we've got an x to the sixth and a y to the second. I just switched them so they were alphabetical. All right, 5 times 2 is what, 10? We've got an x to the first in the numerator and an x to the sixth in the denominator, okay? So x to the first completely cancel, and x to the sixth becomes x to the fifth, good. And then we've got a y to the third in the numerator and a y to the second in the denominator. So y to the second is gone, y to the third becomes y to the first. Okay. Last step, I think. Yeah, it should be. Okay, we're left with 5 times 2, which is 10, and then just a y to the first. That's your numerator. Denominator, just an x to the fifth. And that's as far as we can go. All right, finish copying that down.